Right, thank you. All right, welcome back, I suppose. That applies to most of you. Who has seen my previous talk, the modern component design for the 3.1? Who has not seen it? Okay, that's all right. They are not directly connected, but I will start actually with the for the three kind of one-slide summary. So this talk has a very different purpose. I'm not going to talk that much about the Spring-specific component model. Rather, we take a more strategic perspective and talk about general industry trends, the ecosystem around Spring, our Spring Framework 5.0 roadmap, which is actually a kind of very aligned with the general Java ecosystem and the industry around us. So in that sense, themes and trends is indeed what it is in this presentation. There is a subtitle, and the subtitle is a bit tongue-in-cheek. So there is a degree of reactiveness in this story because reactive architectures is a central theme in Spring 5. We are generally very focused on smaller deployment units, larger system architectures consisting of smaller independent parts, and generally just embedded bootstrapping of containers, fat jars, all of this stuff, even if it's largely Spring Boot and Spring Cloud dealing with microservices, there is a certain microservices orientation or a microservices alignment even in the core framework in the meantime. So that's kind of reactive microservices. The other part is I actually see those as very connected trends. The choice of reactive architecture makes particular sense in a microservices arrangement. Now, on JDK 9, I guess that's somewhat obvious. We are embracing new JDK generations in Springland very, very ambitiously. And of course, JDK 9 is already about to happen. I mean, technically, it was supposed to happen in September, but it will be happening somewhat soon, hopefully. We are tracking it, and we already have some elaborate thinking around it. So I'm going to share some insight on how we position ourselves, how important JDK 9 is from a Spring perspective, what our opinion on that part is. And they're all a little connected anyway, as we're going to see. All of those themes kind of connect nicely into a bigger picture. So where are we to begin with? Currently, we are in the Spring Framework 4.3 maintenance phase. There's 4.3.3 out, 4.3.4 coming. This feature generation of the framework is just a couple of months old. We have a very short release cadence. We basically ship a feature release every 10 months. So this is already, has been the case for 4.1, 4.2, 4.3. They came in reasonably short succession. And they kind of supersede each other. So Spring Framework 4.3 is an immediate successor to 4.2. It's within the same system requirements. This in particular means we are not going to maintain the 4.2 line much longer. So just a little bit of a hint on our maintenance approach. We're phasing out 4.2 now. 4.2.9 is going to be released in December, and that's it then. 4.3 supersedes the 4.2 branch within every major generation of Spring. This is the way we go about it. However, 4.3 is the last feature release in the Spring Framework 4 line. So there's not going to be a 4.4, and 4.3 is up for an extended maintenance phase. What we mean by that, and this extended support life, is best illustrated by the way we're handling Spring Framework 3.2 right now. Spring Framework 3.2 is still actively maintained because it's the last feature release in the third generation, in generation 3. We're still maintaining it. It's actually going to be end of life at the end of this year, but it enjoyed some extended support life for about 4 years after the release of 3.2 to this day. And 4.3 is going to be in a similar position. So Spring Framework 5 happening in parallel, Spring Framework 4.3 basically in active maintenance at this point. Within its system requirements, so no raise of any baseline. It still works on JDK 6 and 7. It works on Servlet 2.5 containers, so back to like WebSphere 7 and co. And for the 3, actually is a pretty rich feature release. So to some degree, for the 3 is almost a little bit of an early backport of 5.0 refinements. You could at least see it like that. Quite a few of the programming model refinements in particular and the runtime refinements in 4.3. In other projects, this would probably be called 5.0. I mean, we really revised a lot of stuff in the codependency injection model. You don't have to use auto-wide on constructors anymore if there's just a single constructor. We refined the injection of collections. We refined the annotation composability model. So there's a lot of stuff that's really worth having. So by all means, if you can, if you're on the Spring Framework 4 line, upgrade to 4.3. There's a lot of benefits waiting for you there. So, and this kind of backport of the completion, backport of the programming model is a sort of completion of the general Spring Framework 4 themes. We had a strong focus on annotation-based components, on the nuances of expressing certain characteristics through annotated classes and annotated methods, annotated parameters. We tried to wrap all of this up in the Spring Framework 4.3 generation here. So this is very intentional. We basically thought like, what's a nice kind of complementing feature refinement here? Let's bring it to 4.3, because Spring Framework 5.0 is basically has a different mission. It's largely infrastructure driven. It's not so programming model centric, at least not to the co-component model. The co-component model basically stays exactly the same. Everything you know about the Spring Framework 4 component model, Spring Framework 4.3 level in particular, very much applies the same way in Spring Framework 5. So the entire annotation-based component story, the endpoint design arrangement, basically everything I've mentioned in my previous talk very much applies to Spring Framework 5.0 unchanged. In Spring Framework 5, we focus on a couple of infrastructure themes. I mean, for a start, we're doing a baseline upgrade. So finally, we raised the baseline to JDK 8+. And I'm going to talk about it, what the implications in just a moment. But not just JDK 8+, but also generally speaking to a Java E7+ baseline with a little bit of Servlet 3.0 tolerance mixed in. We are, in the testing space, we are embracing JUnit 5. So the JUnit 5 generation is itself in its milestone phase. Currently, so it's not a GA version of a GA release of JUnit 5 yet. But we've been an original sponsor. We were among the original lobbyists for JUnit 5 happening. We have an active committer involved in JUnit 5 from our team. So these efforts are somewhat aligned. There's going to be a fine JUnit 5-based test context story in Spring Framework 5. So it's not just about application server baselines and JDK baselines. It's also about other libraries playing an important role in the Spring component model, such as JUnit. All right, so the actual infrastructure themes. I kind of gave them away through the subtitle, I guess, to some degree. It's, of course, JDK 9. We'll talk about that. It's a general HTTP2 topic. So basically the relevance of HTTP2 as an industry standard and everything it takes to build proper HTTP2-enabled systems based on the Spring programming and configuration model. This is related to Servlet 4, but I would almost invert this. HTTP2 is actually more important. Servlet 4.0 is kind of the bonus. And it's reactive architectures in general. So if you wanted to spin it up into an even more extensive subtitle, it's reactive HTTP2 enabled microservices on JDK 9. But that's just a play of words. We are very pragmatic about these things, as you're going to see in just a moment. So we'll dive into JDK 9. As a next step, I just want to summarize quickly what I've already hinted at. There's whatever we talk about here in this presentation, every feature generation, every feature release in Spring is always an opportunity to revise the core container. We've done that in 4.3, as I initially mentioned, quite a few things, quite a few efficiency refinements and feature completion refinements, having made it into 4.3. Of course, that's also happening in 5.0. We won't be talking about it much in the remainder of this session, but of course we're doing that as well in 5.0. And in particular, we are about to make use of our Java 8 baseline. We can finally refine the core container APIs with hard references to Java 8 features, static references in the interfaces, in the classes, in the constructors of core Spring classes. From the Bean Factory interface up to JDBC template or REST template, all of those classes can now be refined to some degree. Like the interfaces can declare Java 8 default methods for existing methods, in particular for newly introduced methods, making the backwards compatibility story, but also generally the implementation of multi-method interfaces more easier than before. We can expose Java 8 API types that might even be more important. The Java util function interfaces, for example, they are new in Java 8, like supply, all of those interfaces in the Java util function package. They can now shine through in Spring declared method signatures in some of our API. Of course, we've done a lot of Java 8 support to your components, to your classes before. Right? So Spring was always auto-adapting to Java 8. So even if you take Spring Framework 4.3 on Java 8 and you're coding against it in Java 8 style, it's going to feel like a Java 8-based framework to you, largely, because the framework auto-adapts to Java 8. If you choose to use Java 8 language features in your code, in your classes, Java 8 API types in your signatures, the framework reflectively understands and adapts to those. So there's basically complete Java 8 support from a programming model perspective, to the degree even of repeatable annotations and other features in Spring Framework 4.3 already. So why the Java 8 baseline here? It's for our purposes. We can internally, in the Spring Framework codebase, the core framework codebase itself, finally use Java 8. This is basically the surface area. You're going to see some benefits in the interfaces that you may interact with, in some of the classes that you may be using that come out of Spring. But there's an even bigger benefit waiting behind this. It's our entire core framework codebase finally being able to use Java 8 language and API features in the heart of its implementation. So it's a chance to revise the entire codebase for Java 8, a Java 8 language update, which helps in many ways. It's a readability update. It's in some cases an efficiency update. So that's already available. If you take Spring Framework 5.0 M1 or M2 right now, all of the Java 8 baselining, a lot of the core container overhaul happened, but some things are still waiting, so not quite there yet. So we already shipped everything up until M2. So even the component index model, shipping an index file to avoid a class path scan, have kind of a pre-computed index where annotated component classes can be found in, instead of having to search the class path. That's new and not particularly well documented yet, but it's already in M2. So in a kind of theme of more efficiently bootstrapping a Spring-based application. There's already quite a bit of stuff that happened. And the component index is one part of that story, some efficiency refinements in the internals of the core container are another part of the story. What's waiting in M3 itself still, that's about to be released in November /M4 in December, is some revision of the way that you could programmatically interact with the container. So in the annotation-based component model, you largely interact with the container through, declarations, right? Like auto-wired constructors, parameter signatures on handler methods, and the container reflectively adapts to what you're providing it with. That's your way of interacting with the container. There was always a large programmatic surface to the containers. You could always go to the Bean Factory, the application context, or even in Spring MVC to the underlying processing architecture and get involved there. You could call methods, or you could implement SPIs. There was always a very well-defined and quite extensive framework surface to work with if you choose to do so. And you can accomplish a lot of things already. What we intend to do in Spring Framework 5, to wrap up the core container story, is a more convenient, functionally oriented way of interacting with the container. Think Java util collection streams like, when you're interacting with a whole sequence of beans, you're trying to filter certain beans with certain qualifiers programmatically, not through a field or method or constructor, but rather asking the bean factory to provide all beans with this and this and this characteristic. And there are nice ideas. We have yet to flesh them out completely on how to express this programmatically using basically a Java util collection like collection streams like style with lambdas or method references as a callback for the filtering functions and kind of interacting with the container that way. This is particularly useful if you're trying to do advanced stuff against the container, or if you're trying to integrate other parts of your code with Spring where you do not want to turn those classes that code into fully annotated components. You rather want to integrate them with Spring container functionality in a programmatic style. And it's also about bean registration, basically an alternative to adbean methods. Because adbean methods are reflectively discovered. The container reflects into the classes, finds the adbean methods, understands the signatures, derives the bean definition from it. In Java 8 style, there could be quite nice if you register not factory methods, but factory functions. Like a Java 8 style function that you can express through a Lambda or through a method reference instead of a factory method. So there are a couple of ideas that are still a little bit up in the air, but that are a key part of what we intend to accomplish at the core container level in Spring Framework 5.0. All right, so much for just a little bit of a detour on what we are of course doing, like revisiting our core container arrangement as we always do in a major feature release. So for the rest of this presentation, I'd like to just pick three areas to highlight specifically. That's our JDK 9 story, the relevance of HTTP 2 in our story, and our attempt or our general attitude towards reactive architectures and the way we see Spring as an enabler for reactive, Spring 5 as an enabler for reactive architectures. All right, so JDK 9. Given the time, I'm going to keep this reasonably brief. There's a lot to say about JDK 9. If you want to have the extended version of the story, talk to me directly. I can share a lot of insight on how things arrived where they are. But basically, almost an executive summary of Spring 5 on JDK 9. Spring 5 was originally very close to the JDK 9 schedule. JDK 9 was meant to go GA, like meant to be released in the final version in September, a month ago, September 2016. That did not happen because there was a delay. They flipped the date over to March 2017. That did not happen either. There was another delay. The target is now July 2017, July next year. We are not going to follow that second delay. We intend to hold on to our March target. So Spring Framework 5.0 we intend it to go final in March, towards the end of March next year. So ahead, a couple of months ahead of JDK 9. This means that the JDK 9 story in Spring Framework 5.0 is going to be early JDK 9 support. But there's going to be a Spring Framework 5.1 after JDK 9's GA release, having kind of a proper production JDK 9 story. All right, so JDK 9 is actually a lot of things, but of course we have to talk about Jigsaw because that's how it's positioned. Jigsaw is the main feature theme, at least according to the JDK architects. It's the main feature theme in JDK 9. And we'll be talking about it in just a bit, based on an example snippet. Jigsaw is basically a modularization mechanism, a static modularization mechanism. Not always GI-like in the sense of dynamically bootstrapping individual parts of the system on the same JVM. Actually much simpler in terms of its design and in terms of its goals. More modest in its goals, you could argue. It's about decomposing this flat, long class path that we are all used to into what's called a module path in JDK 9. So basically giving units of deployment to the JDK with a runtime representation of those units. Because a class path is just a bunch of class files. A jar file is just a zip file containing class files. It doesn't actually have any kind of runtime representation, just its contents are being dumped onto the class path. JDK 9 changes that story, and that's generally a good thing, best explained with a quick example. However, at this point, I would almost like to position it above a Jigsaw introduction. JDK 9 has a lot of other stuff coming with it. JDK 9 brings a new ALPN stack, an HTTP2 enabled SSL stack, out of the box, finally, because that's actually not that easy to achieve on a JDK installation. It brings a new HTTP client, an HTTP2 enabled client, but also a new API design, finally replacing the late 90s URL connection API design. It brings a lot of runtime refinements. It brings compact strings. It brings the G1 garbage collector by default. There's a lot of goodness waiting. There's also collection refinements, or the collection factory methods based on basically an immutable set of elements. Some really overdue stuff that finally made it into the standard libraries. That's all worth having. Just the runtime refinements on its own, the more efficient memory representation brought by compact strings, the garbage collector refinements, the bootstrapping arrangement where the JDK itself is decomposed into several modules and you may choose to only bootstrap the Java base module plus a very small set of additional modules maybe. All of those benefits are available in JDK 9 already. They are largely done. I mean, they could basically ship it. JDK 9 is waiting for Jigsaw to be completed. So all the rest is largely there. Let's look forward to it. When we get JDK 9, this is going to be a worthwhile upgrade. In any case. So just for the runtime refinements, don't change your code. Don't change your compile setup. Stay on target 1.8. But just run on JDK 9 and you're getting some of the runtime refinements completely transparently. This is all worth looking forward to. At the same time, Jigsaw as a central theme, of course, will be something we have to make up our mind on from an application development perspective. From a framework perspective, it's largely about enabling applications, like enabling you guys, to choose a module arrangement, a Jigsaw-based module arrangement for your application modules, for your application jars. So you would still build jar files, but you choose to deploy it onto the JDK 9 module path instead of onto the class path. So if you think about bootstrapping a Java VM like manually, instead of java-cp, you do java-mp. And you put jar files onto that module path instead. So it's actually an opt-in mechanism. You can choose to keep using JDK 9 in class path mode. There's nothing wrong with that. It's not deprecated either or anything like that. So to keep using the JDK in class path mode is a perfectly fine choice, a perfectly fine solution. I actually expect that to be the norm. So even early upgrades to JDK 9 are going to be in class path mode because they are not for Jigsaw, they are for the runtime refinements or for other benefits, for the HTTP2 enabling, not for Jigsaw, right? You can then additionally, once you upgrade it to JDK 9, choose to declare your jar files as Jigsaw modules. Shipping module descriptors, such as the one sketched below. A module descriptor is basically a module info Java file, like a package info Java file, compiled by the Java compiler. A binary representation is included in your jar file, and the JVM just reads them like it reads. It understands the package structure. And module descriptors assign a name, a symbolic name to a module for a start. That's a feature in its own right, a symbolic name for this unit. It can express required dependencies on other modules. It can choose to export just a subset of the contents of this particular module. So you can also restrict the visibility of certain packages. Certain packages could remain internal to this module, to this jar file, not to be seen by other modules. Those are basically the rather straightforward features. The devil is in the details, like the defaults. What's the default for an export? Do we export everything or export nothing by default? Do we strongly encapsulate by default, which means nobody else can see non-public types, not even through reflection, in another module? Or do we weakly encapsulate, like we do on the class path, where other code may reflect into classes and see the private fields, maybe for dependency injection purposes? This is all an ongoing discussion. To this very day, in mid-October 2016, none of those design discussions has ended. So my reasoning is actually that with those design discussions still going on, a feature freeze is several months away. I'm not entirely sure a July 2017 GA date can work with those discussions still going on. But that's just a side note. So from a Spring perspective, if you put your application modules onto the module path, it's a good idea to also put the framework modules that you're using, like the Spring modules, Spring Context, Spring Core, Spring Beans, Spring WebMVC, to put them onto the module path as well. So what happens if you do this? What happens if you bootstrap a Java 9 VM with the module path and Spring jars on it? They are going to be treated as what Jigsaw calls automatic modules. You're actually in the module world. They are going to be wrapped with kind of a module representation at runtime. They are going to participate in module management and module visibilities. You can express requires a spring.jdbc if the spring-jdbc jar file is on your module path, because there's a naming convention, dropping the version number, replacing dashes with dots, and that's the symbolic module name for an automatic module. This is all fine. It's actually almost ideal. If you put the framework jars onto the module path, we can see the other modules on the module path. We can auto-configure ourselves for other libraries that are available on the module path, and we can see your application modules as we should. There's a little bit of a gotcha. At the moment, you have to declare your application modules as weak if you want us to access any non-public members, non-public fields, or non-public methods or constructors. But if you remain bound to a more traditional object-oriented design perspective, you want Spring as a framework to only interact with your public signatures anyway, so even that may be a non-issue. So this is basically our strategic approach at the moment. In Spring Framework 5.0, we want to enable you to opt into Jigsaw, to declare your application deployment units as Jigsaw modules, and to put the framework modules onto the module path, and everything working smoothly. We do not intend to actually ship module descriptors. We don't have to, because there's automatic modules, and those semantics work fine for that perspective. Our perspective is rather, it needs to work for an application development model. You need to have a fine experience using Jigsaw in your application modules on running against Spring, running on Spring. Whether the framework internally ships module descriptors or not, or aligns with the automatic modules conventions, is a detail and not relevant to the larger picture. Not really relevant at this point anyway. So that's kind of the Jigsaw story. But once again, Jigsaw is kind of the bonus in JDK 9, from my perspective, from a Spring perspective. Please consider an early upgrade to JDK 9 for all the other reasons, even if you have no intentions to use Jigsaw. All right, and one of those reasons may be HTTP 2 enabling. So in all brevity, the importance of HTTP 2 is, we cannot really overstate it. It's been out there for a while already. It's obviously an industry standard that matters to each and everything we're doing. It's the central communication protocol for all of our web architectures out there. So by all means, just for the very sake of a new version, we need to embrace it. We need to be able to get the benefits out of what HTTP 2 provides to us. And there's a lot that it provides. The binary representation on the wire, a connection multiplexing that's like so overdue to finally allow browsers to have several logical connections over a single channel. The idea of headers compression, such an obvious feature. Instead of every HTTP request sending the same text amount of headers again and again, the first one sends it, assigns a a kind of ID to this combination of headers, and follow-up requests just symbolically refer to the same headers as before, which can save quite a lot of bandwidth, in particular in scenarios with many small requests going over the wire, such as in a mobile environment or in many modern web architectures in general. So anyway, without pitching HTTP2 too much, I don't think it needs to be pitched because it's such an obvious improvement in every single respect. If for any reason you got stuck in an article or some discussions about HTTP2 push, the pushing of resources from a server to the client, without the client having asked for it, just send some resources his way. If you're wondering where and when to use this, forget about it. Ignore push completely. HTTP2 is very, very much worth having for all the other reasons, even if you're not making use of the push feature at all. Push is highly debated, and it's a little unclear what's actually most efficient in terms of how to use the push feature. So I would rather leave it up to conventions built into the HTTP server, into Tomcat, into JDK, and not manually override with proactive pushing. And if you have no idea how to use pushes in your architectures, then just don't. Just upgrade to HTTP2 to get all the wire benefits, all the networking efficiency that comes with HTTP2. And there's a lot of HTTP2 enabled architecture out there already. On the client side, all the browsers did their job. You name them, right? They basically all have an HTTP2 story for quite a while already. A lot of the networking infrastructure out there, even the cloud providers out there, did the job in terms of their infrastructure upgrade. There's just one piece missing. It's our servers, in particular our Java-based service here, actually accepting HTTP2 connections. So we need to embrace it as well. We need to do our job. We need to enable our server-side web stacks to actually understand and accept HTTP2 and not downgrade all of those new fancy clients to HTTP2 1.1 to that 20-year-old protocol. So how would you accomplish this in a modern-day Java-based web stack? I would strongly recommend to check out the latest generations of Tomcat, JDK, and Undertow. You may have a look at Servlet 4. Just don't expect much to be in there. Servlet 4 is a draft from last October. Nothing happened since last October. It's basically dormant for about a year. Servlet 4 has the mission of enforcing HTTP2 support in servlet containers. And there's a couple of features coming with this, a couple of API features. But frankly, it's not actually that important, because a lot of the benefits in HTTP2 are completely transparent. You can get them just by upgrading the web stack, the servlet stack, your servlet container, to an HTTP2-enabled version, and to actually configure the runtime arrangement to actually make HTTP2 available, to actually accept HTTP2 from clients. So you don't need a Servlet 4 container for this. It almost doesn't deliver a real benefit unless you're in this business of pushing resources, which I wouldn't recommend anyway. So just basically Servlet 4, nice to have at some point, enforcing support for HTTP2. For the time being, it's much more important that the servers that we have available, formally they might be Servlet 3.1 based servers, but we don't care too much, right? Tomcat 8.5, JDK 9.3, recent generations of Undertow, they all have an HTTP2 story in some form. They can at least be configured as HTTP2-enabled web stacks. It might take some effort, but they all come with documentation on how to achieve it. You might have to modify your JDK installation a little bit with some endorsed library stuff in the SSL stack. Just follow their description, set it up, and give it a try, give it a spin. It might be easier than you think. So please do not wait on Servlet 4.0. I've seen too many even stakeholders like vendors out there trying to play that card. Like, we don't need to do this right now because we're waiting for Servlet 4. No, let's not wait for Servlet 4. We're now in late 2016. We need to get our act together now and HTTP2 enable our web stacks now and not end of next year. All right, so from a Spring Framework perspective, it's actually an ongoing theme. Even in Spring Framework 4.3 and Boot 1.4, there are a lot of HTTP2 enabled options already, like support for Tomcat 8.5, JD 9.3 and co. If you choose those containers and kind of set it up accordingly, you can get a nice HTTP2 enabled web stack with Spring Framework 4.3 and Boot 1.4. In the Spring Framework 5 generation, this is all going to be a little more first class. Some API features exposed, dedicated Servlet 4 support, even if it's early Servlet 4 support ahead of the spec release. Support for the JDK 9 HTTP client, once it goes GA. And a general embracing of further containers out there, further servers out there that happen to ship an HTTP2 story. So it's actually an ongoing theme. We initially thought it's a Spring Framework 5 focus theme, but it's once again something that we kind of brought forward to 4.3, very pragmatically, to enable HTTP2 stacks right now in production, and kind of leave the bonus features like support for push resources, for pushing resources, and in particular Servlet 4 support, leave it up to Spring Framework 5. In the meantime, we even have to leave it up to Spring Framework 5.1 because Servlet 4 is not going final before September next year. That's already very clear. And we're not going to wait for that either, just like we're not waiting for JDK 9. All right, so much for my HTTP2 pitch. Let's dive into our reactive architecture model. The Spring Framework 5 reactive web story is largely driven by the Reactive Streams initiative. And even predating the Reactive Streams initiative, there's this reactive manifesto. I don't really like manifestos, but the terms are actually quite established in the meantime. And I mean, they hit the right spots. In a reactive web architecture, you're optimizing your web stack for consistent and predictable behavior under high load. And of course also for efficient interaction with lower load. But it's particularly worthwhile in high load situations where traditional servlet stacks just run into limits. You can only extend the servlet thread pool so far. If the thread pool is exhausted, if all the threads are busy waiting for some other service or some other data store to return, if they're all blocking, you can't accept a single request in a traditional servlet arrangement anymore. Because there's no thread to assign to it. In the servlet model, that's unfortunately a limit you can run into rather easily. Because if a request comes in, the traditional servlet approach is to kind of own that thread, start processing, and only when you're done, you're going to let go. And that get done part can actually be quite late, right? You're waiting for some external service to stream some data back to you, and only when it's fully streamed back, then you can actually return, and you're blocking the thread in the meantime. In a reactive web architecture, you're trying to avoid that at any cost. No blocking. No blocking of a processing thread that's attached to an HTTP endpoint. So it's about responsiveness, about the ability to respond to simple requests, even in high load scenarios within a reasonable time. It's about resiliency to quite some degree, about the ability to kind of recover from scenarios where a third service might not just take long, but might have gone, and you're just waiting for your JDBC connection to finally time out at some point. A more efficient way of handling such scenarios is part of this story. And the whole elasticity is kind of related to cloud deployments anyway, where we would also like to build units of web deployment that can be elastically scaled in a more flexible way than traditional server containers can. Anyway, so basically the manifesto gets a lot of interesting points out there, but what we really care about from a Spring perspective, from a technical infrastructure perspective, is the Reactive Streams initiative, the Reactive Streams specification. This lives under org.reactivestreams in its canonical form. It's an open source project, a very simple interfaces, a very simple API, modeling the interaction between different parts of a processing stack, different parts of an I/O processing arrangement in particular. In the end, it's a very simple publisher-subscriber model with a subscriber being able to ask for further elements, being able to request further elements from the publisher, a kind of mechanism for flow control. So the idea underneath, behind reactive streams, already developed ahead of it. Quite a few stakeholders involved, like the RxJava people, or from the akka side, from our own Reactor project, which is actually a pivotal sponsored open source project. So this is not new. This is more of a general agreement between teams who have been working on reactive libraries and reactive frameworks before, but needed more interaction, more interoperation between different providers. And there are many different pieces involved. Reactive interaction starts at the HTTP endpoint level, at the HTTP engine, but it goes down all the way to the interaction with your data stores, the data store drivers that you're interacting with, and back up. So we're going to get to that in just a bit. Our focus in Spring Framework land is on the Reactor project. The project Reactor 3.0 recently went GA. But stylistically, that's not so different from RxJava. If you're used to RxJava and to the RxJava observable way of expressing operations, then you'll find yourself comfortable even with Reactor 3.0. The API type may be named Flux, but in many cases, the same operations are available as in observable. I'll go into the RxJava Reactor alignment in just a little bit more. So reactive streams interaction is a very simple mechanism for flow control in the end. But it can be super important to model so-called back pressure based on reactive streams, as we're seeing it here. So instead of a publisher just pumping out data without caring whether the subscriber is even able to process it any further, there's interaction between a publisher and a subscriber to only spend time processing data and waiting on data whenever data is actually available. The idea is pretty simple. At runtime, this model is ideal to be bound to an event loop where a limited number of threads can manage a large number of requests, only calling those requests back, the publishers back, whenever there's actually data to process. So there's a flow control model. There's in particular a model for data availability baked in. Even between pieces from different vendors. That's a key part here, because you're not getting your HTTP server and your reactive data store driver from the same group, right? They come from very different angles. You may be using our HTTP web stack. You may be using the Couchbase reactive data store driver, or the one from Mongo, or any other efforts that are ongoing. Those pieces need to be able to interact this way, because in an event loop, never ever block the thread that you're being called back by. An event loop is really meant to be fine-tuned for the number of CPU cores available, like one thread for the core, warmed up CPU caches, and just doing the most efficient callback style interaction with the active I/O streams at any given point of time. None of those I/O streams, none of those requests owns a thread. They are just being called back to process a further piece of data. All right, so it's a very fundamental idea that's baked into the infrastructure, but in the end, it's largely transparent to you. If you're building a reactive web architecture, the idea is that you're building endpoints, somewhat similar to how you're used to, but actually quite different in terms of the way that you're interacting with other processing operations. But you're building HTTP endpoints. That doesn't change. So we're going to see that in just a bit. It's a Spring, in Springland, it's stylistically aligned with Spring MVC, so it looks like a Spring MVC controller, but it actually runs on a different web stack. In Spring Framework 5, we have two web stacks in parallel, a servlet-based web stack and a reactively enabled web stack, and a choice of endpoint models on top, one of them being very similar between Spring Servlet MVC and reactive endpoints. That's actually best explained on a source code example, which you're going to see in a moment. Stack-wise, just to be very clear about this, separate stacks means If you upgrade to Spring 5, you can keep using Spring Servlet MVC, Spring MVC on the servlet stack, as you're used to, with all the integrations, all the SPIs, all the exposure of the Servlet API. You can still declare HTTP servlet request in your handler method signatures, and it's going to work. It's an evolution of the stack that you basically embraced back in Spring Framework 3, Spring Framework 4. We are not trying to abstract that away at all. The similarities, the alignment, happens at the endpoint level on top. In Spring MVC, you're used to declare controller beans with request mapping methods. So stylistically, there's a kind of design recipe for what endpoints look like. We are using the same recipe, the same style, even the same annotations on the web stack, on the reactive web stack as well. You can choose to build in the same style, you can choose to build controllers with request mapping methods running on the web stack, on the web reactive stack. Granted, those controllers cannot simply just magically run on one stack and the other and do their job. You are coding against the reactive stack. You're just using stylistic elements that are identical to a servlet-based model. And we're experimenting with other ways of using the web reactive stack. I'm going to show you that as a final note. So what can this look like? To give you an early idea, this class is a reactive web controller running on Spring 5's reactive web stack, possibly on Netty, possibly on an embedded JDK or Tomcat or Undertow. From a quick glance, it might look like a regular Spring MVC controller. Right? Stylistically very similar, structurally very similar. Well, there's get mapping and there's the get mapping annotation involved, which is a for the 3 feature, basically request mapping method get, but that's a for the 3 feature, not specific to the reactive stack. So if you look a little bit closer, this is not a regular Spring MVC controller because the methods here, like get user and get users, return special reactive types. Get user returns what's called a mono, which is that's in Reactor 3, the representation of a single element or none in a reactive processing pipeline. So it's a little bit like Java util optional, but there's a whole reactive processing pipeline attached to it. And a flux is basically ArcsJava observable. It's a representation of a stream of elements. So in get users, where you would otherwise maybe return a list of user, in a reactive web architecture, you would return a flux of user. And we're at the endpoint level here. So we're actually returning this to the web engine. The Spring 5 web engine at runtime natively understands what you mean when you return a mono or flux. By the way, you can even return an ArcsJava observable here. We understand that as well. We are reflectively adapting to the signature. You can return a completable future to us. We know what to do with it, even if the expressiveness and semantic of completable future is quite limited in comparison to a flux. So the most important part here is you're typically not just magically building those processing pipelines on your own. You're usually delegating out to other components, like a repository. The repository may then be delegating to a data store driver. All of them building a reactive processing pipeline. In this case, we assume that it's reactor-based, based on Flux and Mono, and then passing it back up to the web stack, to the HTTP engine. So that's why I'm showing repository interaction here. That's the norm, not the exception. You want to interact with reactive drivers underneath that are able to push data your way back up to the HTTP stack in the same architectural fashion. So that's the annotation-based model, basically syntactically and stylistically, structurally aligned with Spring MVC, but you are coding on the web stack, on the reactive web stack. The moment that you look onto the signatures here, it's immediately obvious that this controller has been designed for the reactive web endpoint model, as it has to be, because you have to code in a very specific style and only make very specific assumptions when you build a reactive processing pipeline. We are experimenting with another way, and this is actually quite new, just a few weeks old. So initially you might be like, what? Well, let's look again, right? This is actually expressing the same endpoint arrangement, the exact same endpoint arrangement that we've just seen before, but it's using a very different syntactical model. This is what we call a router function, There are a few static inputs involved here that you are not seeing on the slide. So there's kind of an implicit input to our router functions class and our request predicates class. That's where, for example, the route method comes from and where the from publisher method comes from. But essentially, it's the same endpoint arrangement. An incoming GET request to a specific user by ID is bound to what we call a handler function. The handler function has a request coming in and is then supposed to process that request, to build a processing pipeline for that request. So in a reactive coding style, it starts from a path variable, maps that path variable to a long, because that has to be explicit here. There's no auto conversion against the signature after all. And then we pass the result, the long converted path variable, into the repository find by ID method. We are using Java 8 language style here. This actually looks very similar to a Java util collection stream arrangement in the end, because that's what Mono and Flux are very aligned with, a functional interaction with a sort of collection, right? A hot stream source in this case. Then we build an HTTP response, status OK, and we convert our publisher, because Mono and Flux are reactive streams publishers. We convert it to what we call a body inserter, pass it into the response builder, and return that response. This is subject to change. Some details may change. There may be an overloaded method where you don't need from publisher anymore, but that doesn't really matter, because it's about a Java 8-oriented, functionally styled endpoint registration model. This is using basically our little router function, handler function arrangement with lambdas. If that looks a little bit too alien to you, you may find yourself in more familiar territory if you decompose it like this. The exact same code following a different Java 8 arrangement using method references instead. Handler delegate : get user is a Java 8 method reference. So instead of an embedded nested lambda expression for the handler function, we point to a method with a Java 8 method reference. This is super efficient. The Java 8 compiler knows what to do. It auto-adapts the signature to the handler function interface and passes it into our processing arrangement. Of course, this way you've got a programmatically composed arrangement of routes. Imagine there are 10 or more of those routes, each of them one line pointing to a particular endpoint method with a method reference. And then you've got one or more classes with the actual endpoint methods on them being bound to from that router function. So this is sort of in between. It's a little bit handler method style, but it has nothing to do with annotation-based dispatching. There are no annotations involved here. There is no reflection involved here. The handler delegate bindings here, based on Java 8 method references, are direct dispatches to the method. There's no reflection. So this is a new, a different way of using our underlying reactive web stack, modeling the same kind of HTTP endpoint arrangement in a programmatic functional style. This is introduced in 5.0 M2, so if you'd like to read up on this, there's an extensive blog post on spring.io/blog discussing the design behind this, the design vision behind this in more detail. If you'd like to see general discussion of the annotation-based reactive controller model or the underlying use of reactor, like what is a Flux, what is a Mono, we have dedicated articles on all of this, on all these perspectives on our blog. So just Google for it or search on it on spring.io/blog. I can only really kind of whet your appetite or give you an impression of what this feels like in the given time here. All right. So we're done. So just to summarize, quite a few things happening in Spring Framework 5, but in a kind of big picture arrangement, central infrastructural themes, our JDK 8 baseline, a general focus on early JDK 9 support, a general focus on HTTP enabling, one of the reasons why I might upgrade to JDK 9, but also something that we spend a lot of time on, both in Framework and Boot. And our reactive annotation-based controller model, our new functional endpoint model, router functions, handler functions, functionally composed web endpoints, and just a general focus on an embedded bootstrapping arrangement, because what about making your router functions and annotated reactive controllers actually work at runtime? You need to bootstrap an underlying engine. We've got all the pieces in place there, like booting an embedded Netty or embedded Tomcat, attaching our dispatcher to it, or our router functions to it, and it just works. But there's a natural tendency for that to be an embedded HTTP service. So there are quite a few things coming together here. All right, so more on this on our blog, and let us know what it feels like. It's all still brand new, a perfect time for feedback to come in. So thanks for your attention. Enjoy the rest of the show.
Thank you.